So this is the second part of section 2.8. We're going to be solving linear inequalities using both properties, the addition property and the multiplication property that we talked about in the last video. Okay, first things first, we need to simplify each side separately. So that may involve clearing any parentheses, any fractions or decimals, combining like terms. You're going to get the variable on one side, the constant on the other. And you're going to multiply or divide by the coefficient of the variable, keeping in mind that you may have to reverse the symbol if you are multiplying or dividing by a negative number. So this right here, don't forget, reverse the direction of the inequality symbol only when multiplying or dividing by a negative number. Okay, so if you multiply or divide by a positive number, do not reverse that symbol. Let's get that out of the way. Okay, we have 5x minus x plus 2 is less than 7x minus 5. We are going to simplify each side. So I have 5x minus x is 4x. And then I'm going to get the variable on the same side. So I'm going to take my 4x and subtract it from both sides. More than ever, it's really important to keep that variable positive if possible. Sometimes it's not, but if you can, it's easier to work with if it is positive. So we are going to divide by a positive 3. And we have 7/3 is less than x, and we're going to rewrite it so our variable's on the left. So we got to reverse that symbol, 7/3. Okay, now we need to graph it. Well, a lot of students struggle with graphing an improper fraction. So easiest way to do it is to make it a mixed number. No, I don't want the answer as a mixed number, but by the way, do you remember how to make it a mixed number? 3 goes into 7 twice, and we have a remainder of 1. So that's 2 and 1/3, which means that it's going to be somewhere between 2 and 3, probably a little bit closer to 2. So here, right here, label it with 7/3. All right, I'm going to be shading to the right. I do not have an equal sign underneath, so I'm going to use parentheses. And for interval notation, my number on the left, where my shading starts on the left, is 7/3, which has parentheses. And my shading keeps on going to positive infinity on the right, and again with parentheses. All right, we are going to distribute, and don't forget this is a little negative one. We have to distribute the negative. Students always forget to distribute the negative to this number right here, so pay particular attention. So we've got 4x minus 4. Distribute negative 2x minus 1. We're going to combine like terms on the left. Combine like terms on the right. Okay. So we want the variable to be positive if at all possible. So by adding 2x, that will give me a positive x. We're going to add 4. Guys, if you have a negative number and a positive number, you're adding those together, you're going to actually subtract the numbers, take the sign of the bigger one. So it's going to be a negative 12. Divide by a positive 3. Since I'm dividing by a positive, I do not reverse the symbol. I have x is less than or equal to negative 4. My variable's on the left, it's pointing to the left, so I will shade to the left. It has an equal sign underneath, so I'm going to put a bracket right there. For interval notation, it's going to go off indefinitely to the left, so that gives me negative infinity. And on the right, it stops at -4, and it has a bracket. All right, we've got fractions, so we need to eliminate the fractions. We've got a 2 and a 5. The least common multiple between 2 and 5 is 10. That's the smallest number that 2 goes into, as well as 5. So we're going to multiply both terms by 10. And notice it's a positive 10, so I don't have to worry about reversing the symbol. You're going to divide by the bottom, multiply the top, weight to distribute. It's greater than, divide by the bottom, multiply, weight to distribute until this step right here. Trying to distribute at the same time, you're going to end up being confused. Just don't even do it. Now we distribute 15x minus 5, 2x plus 8, subtract my 2x, 13x minus 5 is greater than 8, and add my 5. 13x is greater than 13. I'm dividing by a positive 13. I do not have to worry about reversing the symbol. X is greater than 1. So I'm going to shade and use parentheses. Interval notation. On the left, my shading starts at 1. On the right, it goes on to infinity. Parentheses on the 1, and infinity always gets parentheses. All right, applied problems. Okay, when we see this is more, not more than, but is more than, that tells us we're going to have an inequality symbol. It's going to be greater than, like this. Okay, is more than, not just more than. If I just say more than, that it's not an inequality. But if I say is more than, x is greater than 4. Is less than, then we're going to use the less than symbol. Exceeds, that it means greater than. Is at least greater than or equal to. Is at most less than or equal to. Okay, so this is how we translate English words into inequality symbols. All right, Maggie has scores of 98, 86, and 88 on her first 3 tests in algebra. If she wants an average of at least 90, so we're going to do her greater than or equal to. After her 4th test, what score must she make on the test? Notice we said average, and we have 4 tests. I love to put this question on a test or a quiz, and people get it wrong because they forget there are 4 tests. When we find an average, I've got 4 numbers. I have to divide by 4. People see the 98, the 86, and the 88 and think there are 3 tests, when in fact she's taking a 4th test. So we know she has a 98 and an 86 and an 88, but what we don't know is her score on her 4th test. And she wants to have at least an average of 90. So it has to be greater than or equal to 90. So we are going to simplify the left. We're going to add 98, 86, and 88. So right now I have 272 plus x. Okay, now I've got this 4. Remember, if I have a fraction, I have to multiply by the least common multiple of the denominators. And since the 90 has a denominator of 1, we're going to multiply by 4. Multiply by 4. We multiplied by a positive number. I do not have to worry about reversing the symbol. So cancel. 272 plus x is greater than or equal to 360. We're going to subtract And 360 minus 272 gives me 88. So if she gets an 88, she will be happy. If she gets an 89, she will be happy. If she gets a 90, she will be happy. But if she gets an 87 on her fourth test, she is not going to be a happy student. Okay, inequalities with 3 parts. So let's say, for example, we have this inequality right here. Notice I've got 3 different parts. It's called a 3-part inequality. So we would have -3 is less than 5 is less than 7. What that tells us is that 5 is between a -3 and 7, which is correct. So when we put an x in the middle, by the way, x is always going to be in the middle. We're never going to put it on the left side or the right side. That tells us that our interval of interest, the x values that satisfy this, have to be between 2 and 4. So when we graph it, we're going to graph between 2 and 4. Now the 2 has this less than, so I'm going to use parentheses on the 2. And the x we've got, or the 4, we've got less than or equal to, so I'm going to use a bracket on the 4. When we do our interval notation, we're going to have parentheses 2, comma, 4, bracket. 2 has to be on the left. It's smaller than 4, has to be on the left. All right, now we have, this is a bit more typical of how you would solve a 3-part inequality. So we have to get the x by itself. You don't move the x, you move everything else. The x has to stay in the middle. So we have to get rid of the -1. We're going to do that first. Now pay particular, this is a 3-part inequality. So when we add 1, we've got to add it to all 3 parts. That's something that students forget all the time. We have to add it to all 3 places. Don't forget, you have to add it to all 3 places. Okay, now we have a -3 times x. Again, we have to divide by -3 in all 3 places, but we divided by a negative, which means I have to reverse the symbol and reverse the symbol. Okay, so I've got -1, reverse the symbol, reverse the symbol. Here's where it gets a little bit interesting. My smallest number has to be written on the left. I need to rewrite this 3-part inequality so that my smallest number, which is -3, is on the left side. Okay, so I'm pointing towards the -3. I've got to point towards the -3. I'm pointing towards the x. I got to point towards the x. Yes, I reversed the symbol twice for 2 entirely different reasons. I reversed it here because I divided by a negative. I flipped it here because I rewrote it so that the smallest number is on the left. Smallest number has to be on the left. We've got -3 and -1, and they're both equal to, so they both get brackets. And there you go, section 2.8.